In section 9.1, we take a look at functions of several variables. Now, so far we've talked about functions of one variable, but to consider functions of several variables, you don't have to go too far to consider its practicality. Think about the temperature of your body. And consider all the possible variables that can affect the temperature of your body. So your body temperature can be affected by your weight. If you have a higher weight, you'll have more insulation. You'll be warmer or tend to be warmer. Height might have an effect on it. You might have more surface area, might have a better way of cooling off. The number of calories that you take in might have a direct effect on your temperature because you might have a higher metabolism, so that's your body heating up and creating energy, right? So these are three different variables that can affect your body temperature. When we consider functions of different variables, we'll start off considering a function of two variables, x and y. For example, f of x comma y equal to x plus y plus 3 is an example of a function of two variables, x and y. We can evaluate these functions at different combinations of x and y. For example, we can plug in 2 in for our x's and 3 in for our y's. So we'll be plugging 2 in for our x's, 3 for our y's, and adding these values up, we will have 8. So this function, when your x is equal to 2 and your y is equal to 3, the third value of an 8 will be considered our z component. And this is an ordered triplet, which is the output of our function. So we can think about taking this ordered triplet and graphing it in 3 dimensions on our x, y, z coordinate system. We'll go 2 units out for our x's, 3 units to the right for our y's, and 8 units up for our z's. So again, going this way 2 units, going that way 3 units, and going this way up 8 units gives us this point right here. And this should feel a little familiar. It's almost like what we did with vectors, except that in this case, we're not creating a vector from the origin to that point. Instead, that point itself is the point we're interested in. As you can imagine, we can plug in different combinations of x and y and get different values out. And when we collect all of these values, we get a 3-dimensional graph. To help us visualize this, we can call up on a 3-dimensional graphing utility called GeoGebra 3D. So online, you can go to www.geogebra.org/3D, and it takes you to the GeoGebra 3D calculator. In case you ever forget, any of these details, you can go to Google and type in GeoGebra 3D, and it'll be the first link. So here I can type in f of x comma y is equal to x plus y plus 3. Press enter, and what we have here is the graph of our plane, of our 3-dimensional graph. Let me turn this off for just a second to make a little quick note. When working in a 3-dimensional system, we'll have an x-axis, a y-axis, and a z-axis. In GeoGebra, the x-axis is this axis in red, and I typically like to have this x-axis having its positive values pointing out towards me. The y-axis in green, I want these positive y values to be pointing to the right. And for the blue axis, the z-axis, I want the positive values pointing upwards. So this is the standard orientation that you want the x, the y, and the z-axis when you're graphing things in 3 dimensions. So turning this back on, we have a piece of the overall graph of this function, and this guy is in 3 dimensions. You can rotate it to get a better sense of how it looks in 3D. Right? So this surface is made up of infinite many points that I get when I plug in different combinations of x and y.